Before we start animating our character, I'd like to talk a bit about rotations and how Blender and 3D applications in general handle them. One key component to understand is that orientation and rotation are two different things. Rotation is the action or the motion of rotating around an axis or multiple axes, while orientation is the result of those rotations at a specific moment in time. In this example, the orientation is where the arrow is pointing at. It's currently oriented straight up because it has no rotation values. So what we see per frames are just orientation. And when we have different orientation in sequence, we can simulate a rotation. In this example, I have a bunch of different arrow objects with different colors, and they all have different orientation and they will appear only on one frame at a time. But if I play the animation and I display those different arrows with different orientation in sequence, we feel like there is a rotating arrow. Don't worry, you don't need to think about this whenever you're animating. What I'm just pointing out here is that you can bring the feeling of rotation or rotating motion in different ways. And sometimes your graph editor might not exactly reflect the sensation of rotation you have playing in your animation. In this next example, I have two arrows with exactly the same orientation, but one is rotated by 360 degrees on the x-axis while the other one has no rotation. And if I insert a keyframe for the rotation channels of those two arrows, we can see that for the same orientation, we have two different values. So the rotation motion would be a variation of those values over time. But if in this case I do a 360 degree turn over only one frame, I don't see any rotation on screen. So it's kind of a stupid example, but my goal here is to show you that even if the graph editor is outputting a rotation motion, the feeling on screen or in your output might be different. And so it's very important to check your motion path, your arcs, and your spacing whenever you are animating a rotation. In the end, when we are manipulating a rotation curve, 99% of the time it does make sense and it's logical. But sometimes, especially with quaternions, it won't be logical at all, and it's better to focus on the output than how you got there. Let's have a quick look to the different rotation types and when to use them. You can change the rotation type of most items in the transform panel by clicking in the rotation menu. We will find quaternions rotation mode, different Euler rotation, and finally the axis angle mode that we won't be talking about because I never ever use it. Eulers are very cool because they are very easy to understand, especially when manipulating only one axis. You can input the value you want on the rotation axis of your choice, and the object will rotate around this axis. For example, here around the x-axis. And the cool thing about Euler rotation on one axis is that it's very easy and logical to read in the graph editor. To illustrate it, I will create a full revolution animation around the x-axis. A revolution around one axis is a 360 degree rotation, in this case around the x-axis. I will then add an empty that I will parent to the arrow, placing it on the tip of the arrow and calculate its motion path so that we can see the spacing of our revolution motion. When we now watch the result, we can clearly see the difference of spacing around frame 15, where the curve has the most value variation, while around frame 0 and frame 30, we have some easing. So single axis Euler rotation curves are super easy to read. And they are the perfect choice whenever you are using a controller that needs to rotate only on one axis, like elbows, finger joints, foot roll, or knees. Since Eulers are awesome, why don't we use them all the time? Let's input a bit of Y rotation into our arrow. With this 30-degree rotation on the Y-axis, I've changed the orientation of the arrow. So how will be its motion now? Will it still rotate around its X-axis? Well, not exactly. It's still doing a revolution, but the axis has changed. It's like we have given it a new orientation before we start the revolution motion. When we input a Y value, it's like we are changing the initial orientation of our arrow. And while the arrow is still doing a revolution motion, it's not doing it anymore around the same visual axis. So why is that and how can we handle this? Basically, to define the orientation of the arrow, Blender is reading the Euler rotation value in sequence. And this is why we can change different type of Euler rotation. It will simply change the order of the sequence. When I say in sequence, I mean that Blender will first read, in this case, the Z rotation axis, then the Y rotation axis, and finally the X rotation axis. So basically it starts by the end. For the XYZ Euler rotation, it will first read Z, then Y, and finally X. For a ZYX Euler rotation, it will first read X, then Y, and finally Z. And this is why, in a way, we feel like the Z-axis and the Y-axis are giving a different orientation while we are executing the revolution around the X-axis. But this is not exactly true. And what happens if we input some motion onto those two axes? If I get rid of the rotation on the Z-axis and now input some rotation motion onto the Y-axis while maintaining the rotation motion onto the Y-axis, we can see we get a very weird motion. And if I track now the tip of my arrow, it's super strange. I will get rid of the interpolation of my curve so that we have a linear motion. And now if I mute the Y-axis, I see my classical rotation. But as I mute the X-axis and have only the Y rotation, we can see that the rotation or revolution on the Y depends on the value on the X, and it totally changed the behavior of the arrow. So this is one of the main issues regarding Euler rotation, and it's linked to the gimbal lock. To illustrate the gimbal lock, we will use this Susan head. I have 3 different rotation objects. Each object can rotate only on one single axis. Red is X, green is Y, and blue is Z. And I will parent the monkey head to the red one to the green one, and the green one to the blue one, so that we can rotate them in sequence as with Eulers. So rotating the X object will make the head rotate. If I rotate the Y object, both the head and the red one will rotate. And finally, rotating Z will rotate everything. I can easily create revolution animation or any rotation animation around the X axis. If I rotate a bit Y, it will change the initial orientation of X, thus the revolution axis of the head. The problem is with this evaluation of orientation through sequence, if I rotate Y by 90 degrees, then X and Z will be aligned. And from there, rotating whether Z or X won't change the behavior of our head. And this is what we call a gimbal lock. We have isolated one rotation axis, in this case, the original X-axis. So to keep things simple, whenever you are using Euler, just forget about the middle axis in the sequence and use Eulers only for 1 or 2 axis rotation controllers. If your controller is supposed to rotate freely around the 3 axes, we will favorize quaternions. When I need to choose which type of Euler sequence I'm going to use, I make sure that the first in the sequence is the most important axis, the one that will rotate the most. The one in the middle is the one I want to isolate, the one I don't want to use, and the third one is kind of a secondary axis. On a foot roll controller, for example, I will favorize the x-axis, and the z-axis will come in second position, and I don't want to rotate around the y-axis. For the shoulder, it's a bit the same. The x-axis will be the main rotation axis, the z the secondary. I keep the y-axis available because I know we can do fine tweaking, but those are going to be very low angle adjustments. Let's have a look to quaternions. With my arrow selected, I will choose in the rotation menu quaternions. We now have 4 channels. When I change the value on x, y or z, the arrow rotates around the x, y or z axis. So it seems to behave as it did before. But that's not exactly the case. We generally use quaternions from a value of 1 to -1. If I set the value on the y-axis to 1, I will see my arrow rotated by 90 degrees around the y-axis, and -y will be -90 degrees. But if I want to do a 180 degree rotation on the y-axis, I will get stuck. As I go beyond a value of 1, which I can do, the arrow will go beyond the 90 degree angle. But there is a lot of easing, and the closer I get to 180 degree, the more and more I need to increase the value, and I won't be able to get to this 180 degree angle even if I push the value to the infinite. If I now try to reach this orientation manually instead of using the value inputs, we can see our y value changing as expected, but also the w value. This value that was 1 got to 0 and is now getting to -1, while the y value is also changing at the same time. And this is because those are not rotation values, but each channels equal an orientation. And the values we are manipulating are the quantity or the weight of each of those orientations we are giving to set the final orientation of our object. This is something that was super well explained on the Sociomix YouTube channel, and I will put a link in the documentation. Here I have 4 different objects, each one has a value of 1 on one of the quaternions input. If I set a value of 0.5 on W and on X, you can see our object pointing down. It's halfway the orientation on W and halfway the orientation on X. I can repeat the process with W and Z, and now the object will be facing us. So I believe it can be a little bit abstract, and it is also for me. The benefit of quaternions is that it will take the shortest path from one orientation to another. So if I use my initial arrow and I will key different orientation in space, and I will then set my curve to linear interpolation and calculate the motion path, you can see those clean arcs going from one position to the other. While if I switch to Euler rotation and key exactly the same orientation at the same time, you will see that my curve changes, and it is kind of zigzagging in a smooth manner. So the big strength of quaternion is to not have any gimbal lock and being able to go to one orientation to the other flawlessly. It's perfect for any tracking motion like the head, the arm, the wrist, or even the spine. But it has some limitation. You can't do a proper revolution with quaternions. It's very complicated to read the curve interpolation since it's generally a mixture of all the channels at the same time. So the best way to deal with quaternions is to track your arcs whenever you are polishing your animation. A classic bug with quaternions is when you're trying to do a revolution and see the orientation flipping. This can happen often, especially if you don't go into a very detailed blocking, and the simplest way to fix it is to animate on once whenever you are transitioning from one orientation to the other and you have this flipping problem. We will probably face these issues in the incoming chapters. Don't worry if it's a bit confusing, you don't need to know all this theory to become a good animator. To summarize, we have seen that the orientation is the result of any rotation at a specific moment in time. A sequence of different orientation can give the impression of rotation motion. You should use Euler rotation whenever you are rotating around one or two axes maximum. Eulers are awesome because they are very easy to read and edit in the graph editor, and you can do a full revolution with them. But they can have a confusing behavior whenever you are trying to manipulate multiple axes at the same time. And you may also encounter gimbal lock trouble. Quaternions won't have any gimbal lock. They have a consistent behavior no matter the orientation you are trying to reach, but the graph editor can be a bit confusing. You can't, or it's very hard to execute any revolution using quaternions.